Hello guys, welcome back to my channel Programming with a Purpose. In this video we are going to explore the problem of image recognition or object recognition in images. This is basically a computer vision problem in which we enable the algorithm to spot the primary image in the primary object in the image. We are going to use vision and CoreML frameworks from Xcode using native Swift. So let's start by creating a UI for this project. So let's start by creating a project image recognition ML in which we are going to add some UI elements in our main.storyboard file that will correspond to our view controller. The UI elements will be an image view and a button that will help us to pick an image from the gallery. We are going to add some images in our gallery so that we can test our code using the additional images apart from those already present in the gallery. So let's start by creating this UI as shown in this tutorial. Here we are extending our view controller with two delegates, UI ImagePicker controller delegate and UI navigation controller delegate. Both of these are necessary if you want to use the UI ImagePicker controller. And then we are adding the source type as .photo library. It can also be set to .camera, and then you will have to add the relevant permissions in your info.plist file. But since we are testing our code in the simulator only, so we can only use the photo library source type. And then we are adding a function open photo library that will be connected to our button pick a photo. So the next thing we are going to do in this code is basically we are going to extend the image picker controller. This function will help us to get the image that we have picked in the gallery when we are going to open it, and that image will be present in the info dictionary with the .original image key. We are going to get that image and put it in our image view as shown in this code. So let's just play the code to see if the image picker is working fine. And as we are going to run, we are going to select different images to see if they are actually being set in our image view. So the next step is to add a UI label in our UI. You can pick the UI label element from the plus sign, as we have added the button and UI image view from there. And then we are going to set different constraints on this label. So follow this tutorial to add this label to our current UI. So here I am going to start with the image recognition part of the code. There is a sample code already present on the website that I'm going to show you here. First we are going to import two of the major frameworks that we are going to use here, the Vision framework and the CoreML framework. And let's start by downloading the code. In the code, when you unzip it, there will be a folder of model. In it there is a model file and an already trained model that is present for object recognition. We are going to import that model into our project with the steps that are shown here. Follow these steps, add this model, and then copy the code that I'm going to show you in the next few minutes. And let's start doing the object recognition. All of the code that I am now going to use it basically is from a link that I'm going to paste in the description box. That is the link that you can use to follow and copy the code from the Apple website. I have modified this code according to my needs and inserted all this code in the view controller to show you how object recognition can work in our case. So basically we are using the prediction struct. This is very important because it gives the final results in a composed form. Classification is a string to which our image belongs. Basically the class to which our image belongs is present in the classification string, and the confidence percentage is the percentage of confidence we have towards that object belonging to that class. So let's follow this tutorial for further code updates. So the first step is to create a classifier that is already present in our model. So we are using a MobileNet model, and then we are extracting a model from it in the image classifier model, and this will be returned by our function create image classifier. This model, it will be used to judge basically our incoming images for the class they belong to. So the next very important function is the format predictions functions. As the name indicates, this is basically to format the predictions we get after the classifier is run on our input image. So it gives us a range of strings. So we are going to extract predictions from it. The top two predictions, they are sorted in descending order, and then the prefix 2 is basically to get the top two results. After that, we are going to extract its name, which is in the classification string, and we are going to put it in our variable name. And after that, there can be multiple names in our list of classification. For example, if the classes are closely knit, for example, if an image belongs to two of the classes, it is a flower as well as it is a rose. So we might get label as flower comma rose comma red rose, sort of these kind of classes. So we will be only interested in our first class. We are extracting that with our line on 71, and we can use that function to get our top class. And then how we are going to return the results, it is basically our name dash in the confidence of percentage we have of that image belonging to that class. So that is prediction dot confidence percentage. So the result will be returned in a form of string with the name of the class and the percentage of the class. Another important function is the vision request handler, and I'm going to show you how we are going to use that function. This basically return our results once the results are returned after the request is processed. The request is basically our image classification request, so it is going to put the values in our prediction struct. So the next function is the image predict handler. This is basically going to get our prediction struct, which will be the results of our prediction classification, and then it is going to set those values in our prediction label. That is basically the label we have used in our UI. So the main function that is going to do this prediction is basically the predict image class function. It is going to get our UI image that we are going to pass it as an input, and then it is going to get a completion handler from our calling function, and then it is going to use a model. The model is created in the create image classifier. That model will be used along with the completion handler to create an image classification request, and that request is basically processed to return a class, and all the remaining part will be done by our handler. So let's see how we are calling this function in our ImagePicker controller. We are basically using the predictImage class function with our image and a completion handler, which is image prediction handler we have already written. All of this code is also present in the sample provided by the link in our description box. You can copy this code from there also and explore other avenues of object recognition. And then now I'm going to run the code, and as you can see that I've used a dog image, and it is showing me the class as golden retriever. That is the label or the classification in the prediction struct, and 0.86 is the percentage confidence percentage. So this is our result we have got for this image. There is a very interesting UI that they support with each of the model in Xcode. I am going to show you how to use that UI to get more information about the model we are going to use it. As you can see, the metadata is shown for the neural network classifier in the MobileNet. Different classes that are supported are shown on your right hand side. Layer distribution, convolution, scale, different properties of basically ANN are shown here, artificial neural network. The input is shown, the output is shown, what is the input, what is the output, class labels, and then you can update this model in the utilities tab. So the very interesting tab that I'm going to show you here is the preview tab. You can add different images here, and the model will be applied to it and classes will be shown. You can see that it is showing golden retriever with 89% confidence. So you can test different images by in the model by just adding files here. So I'm adding another image, and you can see what it is going to show the results. So the result is quite low, so that means the classification might not be that proper. So I've used a forest image, and it has shown me at it as park bench with 19% confidence. So I guess if it is showing 80% or more confidence, the object will most probably be closer to what we imagine the classifier to classify it into a certain class. But if it is lesser than like 50%, then that means that object is not classified properly, or the image is not up to the mark. The details are too much, or the object is not that much highlighted. It is not easier for the classifier to classify it with a good confidence percentage. So that is all for this MobileNet. You can explore more models in this way by adding it into the project and then exploring different tabs to get an understanding of what this model is going to provide you. So this is all for this tutorial, guys. I hope you enjoyed the image recognition using the CoreML and Vision frameworks of Xcode. If there are any questions regarding this code, you can post in the comment section, and subscribe this channel for further interesting tutorials, and do let me know if you want me to make a certain tutorial for a topic. Bye.